Hello, everybody, and welcome to our session. My name is Richard Wright. I am a Manhattan prep instructor based in Brooklyn. I actually didn't go to business school. I ended up deciding to get a joint degree in law and sort of international economics, but I did take the GMAT and almost went to business school. So today we're going to be talking about the quant section of the GMAT. Now, obviously, to do well in the quant section of the GMAT, you need to know all sorts of rules about, how to find the area of a circle and how to find the mean of a set and all these other math topics that are covered on the GMAT. But that's not what we're going to be talking about today, because even if you know all of the sort of material that's covered in the official guide and the other resources, there's still a lot to learn about the GMAT that will help you boost your score beyond that material, right? The material is necessary, but it's not sufficient to really drive an extremely high score, let's say an above 700 score blended on the GMAT. So what we're going to be focusing on today is all the other stuff that you need to think about in order to get a really high score on the quant section. Specifically, we're going to be talking about how to maximize your accuracy and efficiency. And obviously, knowing the rules of the subject matter is an important part of that, but we're going to be talking about other ways to boost your accuracy and your efficiency. And then in the second half of the session, we're going to be talking about how to use effective study tools, how to create study tools that will maximize your efficiency when you're studying and make your learning most effective. Also, feel free to jump in on the chat. I have it right in front of me, so I'll be monitoring it. I will be, working my way through the slides, but I'll be checking it periodically, and I'll try to answer any questions that come up. We're going to be spending about half an hour on each of these topics, just as a heads up. All right, so jumping right in. When we talk about maximizing your accuracy and efficiency, there are a few different things that come to mind. The first is a process called UPS, or Understand, Plan, Solve. And we're going to be walking through what that means. Basically, it means not jumping headfirst without thinking into a problem. And then we're going to be talking about how to do rigorous work on the GMAT. A lot of people sort of shoot themselves in the foot or give up low-hanging fruit points they could have had just by not being rigorous in how they approach the GMAT. So we'll talk about how to avoid that. And then we'll dip our toes lightly in a handful of approaches that we have for problems called test-taking approaches that are a little bit better designed for a test-taking environment than the standard textbook, like algebra-focused approach to problems. We won't, unfortunately, in a 1 hour session have time to really teach all of those methods in depth, but they are covered in Manhattan Prep textbooks, and I'm sure you can find information about a lot of them online. We'll mostly be talking about why they're important, and we'll dip our toes in how to do some of them. So what we're going to come out of today's session with is an understanding of how to use the Understand, Plan, Solve framework to approach problems in a way that's optimal, and how to be rigorous on the GMAT without sacrificing too much speed. And then how to, at least you'll have a hazy understanding of how to use these test-taking strategies that we talk about to boost your ability to do hard problems on the GMAT. So before we get into that, let's talk about traps. A lot of doing well on the GMAT boils down to avoiding the traps that the GMAT has set for you. So what do I mean by a trap on the GMAT? Well, human beings, including very, very intelligent human beings, have consistent instincts, right? Our psychologies work in a particular way. And the people who write the GMAT, as well as other standardized tests, they understand our instincts. They know how most people think, right? They know what kinds of sentences sound good or bad to a native or very high-level English speaker. They know that when people tend to approach math problems that have particular characteristics, they tend to approach them in a certain way. And so because the test writers know the general instincts that most human beings share, they design problems on purpose to take advantage of those instincts, right? So a big part of getting good, and this is true across the GMAT, this isn't just for the quant section, a big part of getting good at the GMAT is learning to recognize the signals for the traps that the GMAT is setting for you, and learning to recognize the kind of psychological pitfalls that most people fall into, and then trying to teach yourself to avoid falling into those pitfalls. And that's one of the reasons that repetition and pattern recognition are so important when studying for something like the GMAT. So first, the first big topic we want to breach here in terms of efficiency and accuracy as I mentioned before, is the understand, plan, solve framework. Now, this is a Manhattan prep strategy for approaching all problems. This is not just for the quant section, although it applies a little more directly in the quant section. The first step is you want to understand what you're looking at, right? So rather than just plow ahead blindly and start doing algebra on the problem that you see in front of you, you basically want to tell yourself to slow down, take a step back, and make sure that you understand what you're getting into before you start plowing ahead and doing work, right? How many of us have had the experience of you spend a couple minutes working on a problem, you're working really hard, and 2 minutes into it, you realize, oh, darn, the approach I took is totally the wrong approach. I really should have approached it from this other angle. But now I'm 2 minutes in and I'm eyeballs deep in algebra. I mean, I certainly have had that experience. And I know most of my students who I interact with face-to-face have. So in order to avoid that, you need to get yourself out of this mindset of, I'm under a time limit, I got to charge ahead, do, work. That's not a mindset that lends itself to avoiding traps or figuring out the tricks that the GMAT is putting in front of you. So before you want to attack a problem, stop yourself and get an understanding of what the problem is asking. Once you've done that, once you have a sense of what are the moving pieces of this problem, you want to plan. What is the optimal approach to this problem, given the kind of information I see in front of me? And only after you've taken the time to plan, do you actually want to start solving it, right? One of the biggest mistakes we see on the quant section, one of the most consistent mistakes we see students making, is that they jump directly to step number 3. They just jump immediately to solving the problem. Sorry, I'm just checking the chat to make sure nobody's asking questions. Okay, cool. So let's walk through what each of these steps means in a little bit more detail. So when I say understand, what I mean is some high-level questions that you want to ask yourself. What kind of a question is this? What kind of information am I given? What is it asking me to solve? What are some quick notes that I might be able to jot down on my paper? So you might think, well, of course, obviously, like if I'm jumping in to do work on a problem, I have to understand it. Like I'm already doing this. What I'm talking about is a little bit different than just sort of like understanding the topic and starting to do algebra on it. What I mean is start looking at what kind of traps are here. What does this problem look like in my pattern recognition of the hundreds of GMAT problems I've done? And what sort of tricks might the GMAT be playing with here? Are there any signals that look like some of the tricks I've learned in the past? And then you want to start planning what is the best approach. And the best approach is not always let's do a bunch of work. There's a lot of strategies you can use, and we'll talk about them later. Estimation, working backwards, testing cases, smart numbers that allow you to avoid a lot of work, especially on hard problems. Those strategies are most useful on hard problems. And you want to make sure that the approach that you're taking is the simplest approach. You don't get any bonus points for heavy lifting on the GMAT, right? No one will ever see how you solve the problem. So if you do it in a really hard way, maybe you'll be patting yourself on the back, but that's not the best strategy. And you also want to think about how to organize your work. So visually, what am I going to be writing on my paper? Where is stuff going to go? I want to make sure that's neat and organized, and I'm not working myself into a corner just because my work is messy and poorly organized. And then finally, you want to start working. And as you're working, you want to make sure that you are, careful and concise in what you're writing. You're not overly messy because it's a very easy way to generate careless mistakes. As soon as you have an answer, you can stop. So this comes into play mostly on data sufficiency problems. I'm going to assume some level of familiarity here. So if you don't know what a data sufficiency problem is, that's fine. You can just ignore what I'm about to say for a minute. But on a DS problem, you don't need to get all the way to an actual numerical answer. As soon as it's clear that you have enough information to answer the problem, you can stop. Right? And then probably the most important single line on this slide is that if you get really stuck, you need to be willing to bail out on a problem. Right? One of the crucial sort of light bulb moments that happens in students' preparation for the GMAT is when they finally realize and accept it is fine to miss a lot of problems on the GMAT. Everyone does. It's virtually guaranteed, especially if you're below like a 750, that you're going to be missing a large percentage, roughly half of the quant section. So it's totally fine to miss a problem. And when you run into a wall, bailing is very often the smart move. So what I recommend doing is take a screenshot of this slide, if you have it in front of you. And we're going to come back and talk about it later. We're going to do a few problems. as we go through the presentation. And we're going to talk about how understand, plan, solve affects how you could approach those problems in an optimal way, and what would happen if you didn't approach the problems through a UPS framework. So grab a screenshot of this, and then we'll be talking about it throughout the session. All right, we're going to jump into a quick problem. It's only half a problem. So here's what I'm going to do. I'm going to give you 10 seconds to try to tackle the problem, because I want to get at sort of highlighting what our first instincts are when we see certain things and how those instincts might not be right. So get ready to do a quick brainstorm of math. And then what I want you to do is message me the answer in the chat, and we'll see sort of what people come up with. All right, ready? Take 10 seconds to think about this problem. All right, that was 10 seconds. So I'm going to go ahead and cover it. We'll come back and talk about it later. I just want to get a sense for what people's instincts are here. Was there enough information given on the slide to answer the problem? So do we have enough information to solve the sort of complicated, ugly-looking equation that was there if we're just told that x equals 3? All right, so we got some answers coming in. We've got a no. Give people another 10 or 15 seconds to think about it. All right, so far the only answer we have is a no. So let's talk about that. That is exactly the trap that this slide is designed to elicit. And the instinct behind why you might think, no, we don't have enough information is very simple. There's two variables, right? X and Y. We have x squared plus 5x over xy, blah, blah. So the instinct is two variables. You only give me information about one. Okay, now everyone's coming in with yes answers now that I've made it clear that that's the right answer. But, okay, so the instinct is two variables. I'm only given information about one. There must not be enough information. Now, that may be, in some situations, the right answer. It is not necessarily the case that just because that's the obvious thing that it must be wrong, right? But what you do need to be aware of is that's the obvious answer, which means it's likely or at least possible that the GMAT is laying a trap for you there. So when you see something that seems blatantly obvious like that, you don't necessarily want to say with 100% confidence that it's wrong, but you do want to ask yourself, am I sure I'm not falling into a trap here? Right? So let's walk through how understand, plan, solve would apply to this particular problem. In the understand step, I'm looking at this and I say, okay, first glance, this is a very complicated equation, right? This is not some simple identity that I know off the top of my head. This is not something you can just immediately look at and solve. So I know I'm probably going to need to do some manipulation of algebra here. Right? In the planning phase, I want to think about what is the best way to approach this problem. Well, whenever you have something that's complicated, your first instinct should be, how can I make this simpler? Simplification is one of the most powerful tools you have available to you on the GMAT. So how can I simplify something like this? Let's walk through some steps we could take. So first of all, I'm going to write out the entire problem. It's going to be a little bit ugly because I'm just typing, which is not the world's best way to do algebra. But it'll be clear what I'm doing. Okay. So this is our question. What is x squared plus 5x, quantity divided by xy, minus 5 over y? So what's a step we can take to simplify this? Well, one thing we might notice is up in the top here, there's an x in both terms. So I can pull that out. If I pull an x out of that, this x squared just becomes an x, this 5x becomes a 5, and we have an x on the outside of the parentheses. Now what we might notice is there's an x on the top of this fraction, and there's also an x on the bottom of the fraction. Those two cancel out, which means this x goes away, and this x goes away. Okay. Now both sides are divided by y. Right? 1 over y is a factor in both of these terms. So I can pull that out. I just have a 1 over y multiplied by whatever's left. So that's xy plus 5. 5. I have a +5 and a -5. So that cancels out. It turns into nothing. What I really have here is 1 over y times xy. You have a y on the a y in the denominator and a y in the numerator. We could actually rewrite this as xy divided by y. And the y's cancel out. So it turns out that this really ugly, complicated looking problem stem is actually asking you a very simple question. The problem is just asking you, what is x? So if I'm given x equals 3, of course there's enough information to answer the question of what is x. Right? Now, this is a bit of a constructed problem, right? I designed this problem specifically to teach this point, but this phenomenon happens all the time on the GMAT. The problem stem, especially on data sufficiency, the problem stem looks complicated. It looks really hard and untackleable, and how the heck am I going to think about that, especially in 2 minutes? But if you just simplify it, it turns out that the actual question the problem is asking you is much, much simpler. And once you've simplified the question, your decision about whether each of the two statements is sufficient or not becomes much easier. So the key lesson here is, by taking a second to pause, think about how to approach the problem, and then realize, okay, anytime there's something complicated, I want to simplify it. That's my plan. Then I do the work. It makes life a lot easier, right? Okay. Also, as always, feel free to jump in if you have any questions or comments on the chat. I will keep an eye on that and we'll respond as best I can. Let me just make sure I'm checking my notes to make sure I'm not forgetting any key points I wanted to make. Okay. I'm going to take my work here and put it off to the side because I'm going to use it as a point later. We'll come back to that. Okay. So that's the understand, plan, solve framework. We're going to use it in all of the problems we do today. We'll do, a handful of problems. So we'll see it again. But keep in mind that really the one bullet point summary of understand, plan, solve is just don't jump blindly into a problem. Go in with a plan that makes the problem as easy and as high probability of you getting it right as possible. Okay. So let's talk a minute about being rigorous on the GMAT, because this is a really crucial way to boost your accuracy on problems. Careless mistakes are one of the biggest sources of error on the quant section. And one of the best ways to avoid them is to be rigorous about what you're doing. So let's talk about what I mean by that. The first is you want to be skeptical of what the GMAT is putting in front of you, right? So a good example is the problem we just saw. That original problem stem looked really complicated and very hard to tackle. But once you start chipping away at it and simplifying it, it turns out it's actually quite a simple question, right? So you always want to be a little bit suspicious about how things appear on the surface in the GMAT, and you always want to be aware of what tools you have to make life easier for yourself, right? And that's a key part of approaching problems in a rigorous way. Is don't just blindly charge in and be like, oh, this is really complicated. Stop, think about it, identify what the moving pieces are, and identify how you can make life easier for yourself by being skeptical of the way that the information is presented to you. Second, you want to write everything down. The vast, vast majority of careless mistakes happen because students try to do too many steps or too complex of a step in their head. Doing work in your head is a very, very good way to fall into the traps that the GMAT is setting for you. The people who write the GMAT know exactly what kind of math is tempting for people to do in their heads, and they will design problems that exploit holes in human instincts about how math works. Even if you think you're really good at math, it's very easy to fall into these psychological traps. So write things down. People think, oh, I don't have time to write things down. I'm under a time limit. I need to be, focusing on moving really fast. It is definitely true that the GMAT is timed, but in a lot of cases, slower is better because it doesn't benefit you to spend a minute and a half on a problem and get it wrong versus spending 2 minutes on the problem and getting it right. So oftentimes a small loss of time for a big boost in accuracy is a hugely positive payoff. One key point I want to note here is when you're writing things down, try as best you can to write actual math and not what I call math-ish, right? So a key example of math-ish is when you write things that aren't equations or inequalities that you can actually do algebra on, right? So if you just write something like 17, there were 17 people at the party, and there were 3 executives. As an initial step when you're first trying to understand the problem, if it helps you to just sort of translate the words of the problem into sort of bullet pointy notes, that's fine as an initial step. But what I want to highlight is sometimes people will write things like they'll just write 17x. Okay, this isn't, what are you going to do with that? You can't do math with that. There's no equal sign, there's no inequality, there's no algebra rule you can apply to just 17x. And the danger of this is when you write this, people feel this sense of like, okay, well, I wrote the problem down as math. I turned it into like a variable and a number multiplied by that variable. So I've translated it into math, but I don't know what to do next. Well, part of the reason you don't know what to do next is this isn't a rigorous math equation. This isn't an expression that allows you to do all of the tools, to use, excuse me, to use all of the tools that you have in your toolkit. Much better to write something like a full expression, 17x equals question mark, or 17x equals 4y, or whatever, something you can actually do math on. So avoid these sort of like math-ish, but not quite actual math expressions when you're writing down. It's okay as a first step, but at some point you need to write down real math. It doesn't necessarily mean equations. It could be, a table if you're doing an overlapping sets problem. It can be a picture if you're doing a geometry problem, but it needs to be something rigorous that you can really do math on. Let me get my mouse tool back. Another really crucial thing to keep in mind is every single quant problem you do, every single one should have a question mark somewhere in some real math. Most of the time, that's going to mean an equation, right? So x equals question mark, right? Down here, if you're trying to solve for x, you want to make that clear to yourself. Or if you're, doing an overlapping sets problem with a table, you put a question mark in the cell that represents what you're trying to figure out the number of. Or if you're doing a geometry problem, you're trying to figure out, let's say, the length of the side of a triangle, you would put a question mark next to that side. This sounds sort of childish and trivial, and people are like, who cares? Why do I care about writing down the question mark? I know what the question is asking me. It turns out one of the most important reasons is because it helps guide your thinking. Right? Let's take the geometry problem as an example. If I have a picture of a triangle on the slide and I have the question mark labeled and I know what information I also have labeled on the slide or on the drawing, excuse me, it becomes much easier mentally to see how you can connect those dots. So the goal is to make the problem as easy as possible for your brain. And one key way to do that is to tell your brain explicitly, visually on your paper, what you're looking for, which helps your brain connect the dots between the information you're starting with and where you're trying to go with it. It also helps you avoid careless mistakes. So I'm a big proponent of always writing down your question mark, in part because the careless mistake that I am most prone to is I'll do a bunch of work. Let's say there's 2 variables in a problem. I'll do a bunch of work. I'll solve for y, and I'll say, oh, y is 17. Hey, 17 is one of the answers. That's the answer. I pick it and I move on. And I forget that the problem wasn't asking me about y. It was asking me about x. So by writing down your question mark and always checking before I pick an answer, okay, is the equation that I'm using to justify this answer, does it match my question mark equation? Because if not, I'm solving for the wrong thing. So those are a few different reasons why writing down a question mark is a really crucial part of solving every single quant problem on the GMAT. Can't emphasize how valuable that is. So let's look back at, there's one more point here. Stay organized, right? That might mean as your work gets sort of more complicated and you get off into a corner and you run out of room and it gets really messy, pause for a second, reset, rewrite the equation, the last equation that you had that you were working with, somewhere else on the paper where you have a little bit more room and you can organize your work better, and then keep going from there. You want to make sure you stay organized, because if you're not organized, it's very, very easy, especially when you're under time pressure and you're not thinking super clearly, to misinterpret something that you've already said. So if we take a look at the work that I did on the last problem, this is a good example of good, organized, rigorous work. The first thing I wrote down was a full equation. It was the problem itself as it was given. I didn't just write down the equation or the left-hand side of the equation, right? A lot of people would just write this down. The problem is this is just an expression. It's one piece. It's sort of like a sentence that doesn't have a subject or doesn't have a verb. You need both pieces for it to be real math that you can work on. So I wrote a question mark on every single line, and then that's what helped me realize at the bottom, X is really my question mark. One of the things that might happen to people that could go wrong if you don't use understand, plan, solve is if you're just writing down this stuff, or if you're not being rigorous, if you're not writing down the question marks, I get down to the bottom here and I just have X. Wait, what does that mean? I just ended up with X. Is this telling me the value of X? Now I'm a little bit confused about what I just did. I did a bunch of work, and I think it was good work because I simplified stuff, but I'm not clear what the conclusion is here. So by keeping your question mark in every single line, when you get to the bottom, it's clear that's the question. That's what they're asking you to do, right? It's what they're asking you, whether you can solve or not. Okay. That's it for being rigorous. Especially the question mark point here, I realize sounds a little bit pedantic, a little bit like instructions for elementary schoolers. And a lot of people think like, well, I'm taking the GMAT. I'm super smart. Trust me. Most of the tips about how to improve your score on the GMAT, other than learning the material, boil down to things that feel really simple, but they have a huge impact. So trust me that this stuff matters a lot. All right, I'm going to give you 2 minutes to tackle this problem that's up on the screen. I'm going to set a timer right now. Go ahead and work on it. And as soon as you're done, feel free to message an answer in the chat. Actually, keep your answers until I tell it's time, because I don't want people giving the answer away to other people. Yeah. At this point, the cat's out of the bag, but I did ask you to keep your answers silent. Okay, so that's time. That was 2 minutes, which is the real time limit per problem on the quant section. So let's talk about this problem. A lot of people have already put the answer in the chat, which is correct. It's 160 C. Before we talk about the correct answer, I want to point out a key trap in this problem that can arise from doing sort of non-rigorous approach to the problem. And a lot of people fall into this trap. In fact, I would bet if I gave people, 15 seconds to solve this problem, most of us would fall into this trap. It's just a very deeply ingrained human instinct. And that's the following. I see, okay, 25%, Abdullah's got more than Francine. So Abdullah is more than Francine, 25%. This is what I'm writing down. It's not very rigorous math. I'm just sort of taking notes. Abdullah is 200. So Francine. Okay. Well, 25% of 200 is 50. So if Francine is less than that, she's got to be 50 less. So 200 minus 50 equals 150. The answer is B. Now, this looks okay. Your math is not very clearly written out. This isn't very rigorously written math. And so it's hard to spot where things went wrong here, right? 25% of 200 is 50, and Francine is less than Abdullah. So why wouldn't Francine be 150? And the reason is because this person didn't translate the words of this problem into a rigorously written math expression first. That's in word problems, you always want that to be your first step. Translate the words into some rigorous form of math. Most of the time that's equations. It's not always equations. Sometimes it's a table or even a diagram, a picture can be rigorous. It just means something precise that you can do actual math on. Bullet point notes like this, text that's not, algebra expressions, that's not very rigorous math. They're fine if you're just trying to summarize the problem at the beginning, but at some point you need some real math to work with. So let's talk about the equation that you get from this first sentence. Abdullah has, we'll call Abdullah, the number of seashells that Abdullah has is A. Has is just an equals sign. 25% more than, well, 25% more than, there's a few different ways you could write that. 1.25 is one, 125% is another. Just to highlight what's going on here, 25% is the difference between the two, but because of the more than, you have to include the original amount, which is why you have the 100%. We're not really talking about percentage topics here. We're mostly talking about strategies for the test, so I'm not going to dive too deeply into that. But the way that I would strongly recommend writing this number is 5/4. Decimals and percents are not as useful for doing math especially in your head, as fractions are. Fractions have tons of really cool tricks that you can do with them. Stuff cancels out when you're multiplying different fractions. If you want to take the reciprocal, like flip them over, very easy to do with a fraction. Taking the reciprocal of a decimal, unless you convert it into a fraction first, is super hard. Multiplying a bunch of decimals together is lots and lots of work. Fractions just make life way easier. So we're going to write this as 5/4. And it's 25% more seashells than Francine has. So that's F. That's the equation that we get from the problem, right? Now, the second thing we want to write in order to be rigorous is what is our question mark? Our question mark here is Francine, how many she has. So in order to go from this to answering how many Francine has, all I need to do is take the information I'm starting with and manipulate it bit by bit, just keep poking it, doing little changes until it looks like this. So what's a key difference between what I'm starting with and what I want? Well, F needs to be on its own in what I want. So I've got to get rid of this 5/4. So how do I do that? I can start out by multiplying by 4, get rid of it on the bottom. So 4a equals 5f. Then I divide by 5. So now I have 4/5 of a equals f. Okay, so I'm just going to rewrite that. Now it looks like my question mark. The problem is I need a number here, right? Well, luckily I have one more piece of information, a equals 200. So now I can just plug this in and solve. 4/5 times 200. Now, some people might be thrown off by this math, but one key thing to keep in mind is if I have a fraction multiplied by stuff, I can apply either part of the fraction, the denominator or the numerator, to the number that's being multiplied. The math will work out. As long as I do both eventually, I can do whichever one I want first. So dividing by 5, it turns out, is actually quite easy. There's a trick. To divide 200 by 5, you first divide it by 10, which is easy because you just knock out a 0. And then you double the result. And dividing by 5 is the same as dividing by 10 and multiplying by 2. So it's a nice quick trick. Now I have f equals 4 times 40. Well, 4 times 4 is 16. And you have a 0 at the end. So that's 160. So this is a good approach to this problem. It's rigorous. I wrote down actual equations, which helped me avoid falling into this trap where I just instinctively think, oh, 25%, 200, that's 50. Take that out of 200, that's 150. The rigorous math saves me from that trap. And I used the understand, plan, solve framework to get there. I didn't just jump directly to solving, right, based on instincts. I looked at the problem, understood what kind of problem it was. It's a word problem. I need to translate that into math. I'm also seeing percentage changes. That's something that the GMAT loves to build traps around, specifically this trap about what is the base that I'm multiplying 25% by. And then I'm going to approach it. My plan is I'm going to approach this problem with algebra in a rigorous way. And that's what I do at the top. And then I start solving from there. I don't jump directly into instinct-based solving. Okay, So that's the key takeaway from that problem. You could also, if you wanted, work backwards on this problem. Now, this is one of the test-taking strategies that we have available to us that I guess I was supposed to cover on a previous slide that I didn't mention. Did I skip one? I accidentally skipped. Oh, no, it's the next slide. Okay, great. So working backwards is a strategy where you take answer choices that are numbers. The answer choices have to be numbers. And you plug them into the problem to make the problem a little more concrete and a little bit easier to solve. Now, on relatively straightforward problems, and I would say this is a relatively straightforward problem, working backwards doesn't save you any time relative to algebra. But if you force yourself to get good at working backwards, if you practice it enough that it just becomes fluid, working backwards is dramatically faster and, even more importantly, less prone to errors than algebra is on hard problems. So it's one of those things where you just force yourself to use it on easy problems, and eventually it pays off because on the hard problems, it's a much better way to approach them. So if we were going to work backwards, we always work with B and D. I don't have time to explain why that is, so just take my word for it. We're going to work with B first. How would we do that? Well, I need an equation. So I already had Abdullah equals 5/4. I'm going to take this answer choice, I'm going to plug it in. Now, what variable are they giving us numbers for here? Well, to figure that out, I just look at my question mark. My question mark is asking, what is Francine? So that tells me that all of these numbers represent F, Francine. So I can take the 150 and plug it in for F in the equation. And then what I'm checking is, do I get the number for A that I expect? Well, the problem tells me A has to be 200. So I want to check, do I actually get 200 when I plug in this number for F? So 5/4 times 150. I'll multiply the 5 by 150 first. That's 500 plus 250 is 750 divided by 4. And 750 divided by 4 does not work out to be 200. It's just clear that that's not. You can. What would be divided by 4 equaling 200 would be 800. So I'm too low. And then we would test 225. I'm not going to walk through all of this because we're a little bit short on time. But you would test 225, plug that in, realize that's too high. And because B is too low and D is too high, that would tell you that C is the right answer. So I realized I didn't really teach those steps in a lot of depth. But if you read the Manhattan Prep textbooks, or I'm sure if you just search around online, you can find a lot of descriptions of how to work backwards. It's a really, really valuable strategy, especially on hard problems. So let's start talking about test-taking strategies generally. So we've all learned how to do algebra. We spent years learning how to do algebra in school, and algebra is great. It's a very powerful tool. It can solve almost any problem. The downside of algebra is it involves a lot of steps, especially on hard problems. And it's not always intuitive what step you should take next. So sometimes you'll work down a path and then realize, oh, that didn't really help me. Let's go back. Now I got to do something else. The big problem is that every single step you take when you're doing a quant problem is an opportunity for two things. Number one, it's an opportunity for a careless mistake. More steps, more likelihood of a careless mistake. And two, it just fundamentally takes time to do more steps. So on hard problems, while algebra is a really powerful tool that will most of the time get you an answer, it has a big disadvantage. It's slow, or two big disadvantages. It's slow, and it's more likely to generate a careless mistake. So there are a few different strategies you can use that avoid algebra, or not avoid, but minimize the amount of algebra you're using. The key thing to realize about these is when you're first starting to use them, they feel a lot less comfortable than algebra, because algebra is something you've been learning for years, maybe decades. You have tons of experience doing it. It's very easy for you. But it turns out that on hard problems, these test-taking strategies are much faster and much less likely to generate a careless mistake, both because they are fewer steps than algebra and because the steps you're doing are much simpler. So I'm not going to walk through all of these, but this is a great list of test-taking strategies that are available to you. Working backwards was one that I just showed a hint of in the last problem. Testing cases is great for data sufficiency problems. Smart numbers is something we'll see a little bit in a while. Basically, the idea of smart numbers is pick a number, and just any number, and plug that in for the variable in a problem and see what happens. It makes things more concrete. The core idea behind all of these, testing cases, working backwards, and smart numbers, is that you're turning algebra, which is abstract and sort of hard for your brain to think about, even if you're really good at math, it's relatively hard compared to arithmetic. Arithmetic involves real numbers. It's just easier for your brain to conceptualize real numbers. What you should do is very straightforward. You can solve the problem, get a real number answer. Anytime you have the opportunity to use arithmetic, which means math with real numbers, instead of algebra, which is math with abstract variables like x, arithmetic is always the better option. Okay, let's try this problem. I'll give you 2 minutes to noodle on this problem. Actually, we don't have 2 minutes. I'll give you 1 minute to noodle on this problem. So think about it for a minute. And if you come up with anything at the end of the minute, put it in the chat. But hold off until the time is up. Okay, that is 1 minute. And obviously, on a real quant problem, you have 2 minutes, but we're a little bit behind, so I'm gonna go for it. If you got an answer, send in your answer here. But the main takeaway that I wanted people to get from this is, if you just try and approach this problem from a standard math approach, it's a really hard problem. You have to think about it a lot. And it's a very easy problem. Even if you're really good at math, this is a very easy problem to have no idea what to do on. What I'm going to do is I'm going to show you the sort of traditional math solution for this. And what I'm highlighting here is it's really hard to figure this out. And then I'm going to show you a test-taking strategy that lets you solve the problem in 10 or 15 seconds. And you might have no idea why that test-taking strategy generates the right answer, but it does. And you're confident that it does even if you don't know why, and you can pick the right answer. So let's walk through how you would do this in a sort of traditional math way. So I'm going to rewrite the problem first. X cubed minus x plus 1. And what I'm asking is, what's the remainder? Right? Now, there's not really, unfortunately, a great simple way in an algebra expression to write what is the remainder. So I'm just going to use this arrow here and forgive my borderline math-ish writing down. But let's simplify this. How can I simplify this? Well, these two terms here both have an x in them. So let's see if it's helpful for me to pull that out. I'm not even sure it will. I mean, I am because I made this problem, but sometimes you don't even know for sure if a move is going to be helpful. But if it's an obvious move to you, take it and see if what you get out of it is something you now know what to do with next. Here, it turns out that it is helpful because this I identify as one of the GMAT's favorite identities to hide. This is an example of a squared minus b squared. You might think, okay, x squared, I see how that's a squared, but how is 1 b squared? It's not a variable, doesn't have a square over it. So how is that the same? Well, 1 is 1 squared. The GMAT loves this identity because it's very easy to hide. A squared minus b squared turns into a plus b times a minus b. And the reason the GMAT loves it is because it's very easy to hide things. I could make this a to the fourth, or x to the fourth minus 9, right? Well, that doesn't look at all like a squared minus b squared, but it is. X to the fourth is just x squared squared, and 9 is just 3 squared. So I know that x squared minus 1 turns into x minus 1 plus 1. And now what I'm going to do is I'm going to just look at these 3 bits. Minus 1. Okay. So these 3 bits, keep in mind that x has to be an integer. Right? So if I rearrange it like this, x minus 1, x plus 1, that's 3 consecutive integers. x minus 1, x itself, and x plus 1. Now, when you have 3 integers in a row, you're absolutely positive that one of those is divisible by 3, because every third integer is divisible by 3. Right? 3, 6, 9, 12. So no matter which 3 integers I pick, as long as they're all consecutive in a row, one of them definitely is divisible by 3, which means that when I multiply all this stuff together, there's going to be at least one copy of 3 in there, because at least one of these numbers has a 3 in it, in its prime factors. So when I mash all this stuff together, this is divisible by 3, so the remainder is 0. Okay. So if the remainder of this piece is 0, when I add 1, what's the remainder going to be? The remainder is going to be 1. This piece has a remainder of 0, and then when I add 1, that's just going to be the 1 hanging out after I divide by 3. So the remainder for all of this is going to be 1. That's really hard to see. The algebra is not super hard. Like, if you can get it to this point, that's awesome. But realizing that this is divisible by 3, that's tricky. So this is highly unlikely, even if you're good at math, to generate a solution, a correct solution, like this approach. Well, what's the alternative? What test-taking strategy could I use here? Well, this is a problem where I could use smart numbers. I'm not going to go into too much detail as to why, because it's a subtle and complicated thing to explain. It takes a little bit more time than we have, but this problem works no matter what value x takes, basically, as long as it's a positive integer. So there's an infinite number of possible solutions I could do. So I'm just going to say that x is some number, any number. I'm going to say x is 2. Because the answer, the remainder when x is 2, has to be the same as the remainder when x is 11, and when x is 10,000, and when x is any other positive integer. Because if that weren't the case, the problem wouldn't make any sense. The problem only makes sense when every single integer x, positive integer x, generates the same answer. So let's just plug in a number and see what the answer is. That's smart numbers. Some people are putting in test cases into the chat. Test cases is slightly different. Test cases is when you're purposefully testing a bunch of different numbers and seeing if you can get different outcomes, which is why it's a useful thing on data sufficiency. Here, we're just picking one number, and I know that the answer that I get from that number has to be the same as any other number I would pick for x. Someone also suggested plugging in. If what you mean by plugging in is just pick any positive integer for x, that's true. You don't really want to plug in the answer choices here, because what do these answer choices represent? They represent the remainder. So how do you plug that in? It's not really clear where you would plug in the remainder. There's not a convenient equation to stick that into. So this is a little different from working backwards. I realize 2, which is the number I'm using, is one of the answer choices. But that's just coincidence. I'm not taking the answer choices and plugging them in. I'm just picking a number out of thin air that will make my life easy. Okay, so what do we get here? We get 2 cubed is 8. Minus x is 2, so that's just 2, plus 1, what does that equal? 6 plus 1 is 7, and then I think about it. When I divide 7 by 3, what's the remainder? Well, 3 goes into 7 twice, you get up to 6, and you have 1 left over. Remainder must be 1. Now, I don't know if this is my approach. I don't know why that worked. I have no idea why that's the remainder, but I'm 100% confident that it's the right answer. So this is a great problem to illustrate why. Someone just asked, what if you picked 3? It would still work. So if you pick 3, I'll do this really quickly. 3 cubed is 27. Minus 3 plus 1. Well, 27 minus 3 is 24. 24 is divisible by 3. When you divide by 3, you're going to have a remainder of 1. Doesn't matter what number you pick, as long as it's a positive integer, because they tell you x has to be a positive integer. So the point of this problem is, if you approach it with just traditional algebra, it's tough. It's really hard to realize that this is divisible by 3, right? But if you do it with smart numbers, it's a 10-second problem. That's how powerful these test-taking strategies can be. Okay, the other takeaway here is, if you didn't realize this, when you go and read the explanation, this is a great subject matter takeaway, right? This is what we call know the code. What we mean by know the code is there are tricks and traps all throughout the GMAT. And you want to know what tricks and traps the GMAT is referring to, right? And a lot of that is just pattern recognition. That's what we mean by the code, the patterns that are hidden in the GMAT. So if you run into this problem and you read the explanation, you realize, oh, that's cool. X minus 1, x plus 1, those are consecutive integers. If you have 3 consecutive integers, they must be divisible by 3. That's a great flashcard. In fact, multiple flashcards could come out of this problem, right? X cubed minus x, how do I break that down in a productive way? Well, it turns into x minus 1, x plus 1. And you want to explain why that's the case. You could have another flashcard about when I divide by 3, if I have a number divisible by 3 plus 1, what's the remainder? Well, it's 1, because the divisible by 3 part has no remainder. So the only remainder is the 1 that you can't divide by 3. So that's also a really crucial approach to studying for the GMAT, is knowing the code, identifying these sort of patterns and tricks that the GMAT is doing, making flashcards out of them, and using those flashcards to improve your pattern recognition on the GMAT. Okay, so the last 10-ish minutes here, we're going to talk about effective study tools. Most importantly, we're going to talk about how to make effective problem sets. This is something a lot of people don't do correctly. And then once you've made a set, how do you analyze what you've done to generate maximum output? So let's jump into that really quickly. When you're making a problem set, your goal is to make it as similar as possible to the real GMAT, right? So the GMAT's not going to give you 9 data sufficiency problems in a row. And it's certainly not going to give you like 9 medium level algebra data sufficiency problems. But a lot of people, that's how they study. They just choose like a topic and a problem type and a difficulty level, and they plow ahead into a bunch of those problems. You want to mix and match. So you want to combine some difference in difficulty level, skewing more towards what your bread and butter is. You know, if you're a 600 level student, you mostly want to be doing 600 level problems, maybe a little bit higher to push the envelope, but it's not worthwhile to do a set that's mostly 700 and 800 level problems for you. But some variety in difficulty level. And you definitely want to mix up both quant problem types in a quant problem set and all 3 verbal problem types in a verbal set. You want to choose your questions randomly so that you're not exactly sure what you're getting. Now, if you want to focus on a particular subject matter in order to boost your abilities in that subject matter, that's fine. That's a good form of practice. But you also want to be doing a fair amount of just mixed sets where you don't know what to expect. You can start with 4 problem sets for quant and then build up towards 16. And 9 problem verbal sets is a good metric. You do want to maintain a time limit. Time limits are 2 minutes for a quant question or a critical reasoning question, a little bit under 1.5 minutes, about 1:20 minutes for sentence correction. And a reading comp passage plus 3 questions is 6.5 minutes. That's about 2 minutes for the passage and about 1.5 minutes for each question. And we also give the time limits down here for if you have extra time. So if you have 50% extra time or double time. Crucial thing about the time limit. You do not want to start a timer on your phone and leave your phone facing yourself so that you're watching the timer while you're doing the set. The whole point of doing time sets is to build up your mental sense of what time feels like and when you should be telling yourself to move on from problems. So start the timer on your phone and then put your phone face down. And when the alarm goes off, if you've only gotten halfway through the problem set, that is a crucial thing you want to internalize so that you build up your ability to know when you need to move on from a problem. The only way to do that is to practice it. It's not something we're just naturally born with a perfect sense of what 2 minutes feels like. But the more practice you get, you'll discover it is a very learnable skill. You'll start to have a pretty accurate mental clock that's just telling you, you know what, I've spent too much time on this problem. I need to bail and move on. It's not worth the additional investment of time. Okay, so that's how you make a problem set. You want it to be mixed, both in terms of difficulty and whatever, and you want to have a single time limit. Let's talk about how to review a problem set. So let's talk about the wrong way to review a problem set. The wrong way to review a problem set is as soon as you're done, you open up the answers in the back of the book, you check which ones you got right and wrong. The ones you got right, you don't do anything with. You say, hey, I got that right, awesome. The ones you got wrong, you read the explanation, you nod your head and say, okay, I get it now, and you move on. If that's how you're approaching problem sets, you are missing so many opportunities to learn and improve and to actually force yourself to prove that you're getting better. So let's talk about how to do that. Firstly, you don't want to jump directly to thinking about which problems you got right and wrong. That's actually not the most important high-level thing when you do a problem set. The first is you want to think about the problem set as a whole, as an entity. Did you make smart decisions about when to move on? Did I get sucked into a 4-minute time trap on this one problem because I just refused to give up and bail on it? Were you super stressed? If you're super stressed, that's something you want to start working on now. There are ways to work around it. Positive self-talk, A lot of practice can help, but that's something you definitely want to be aware of and start working on. And you want to think about, just at a high level, what did I do well in this set and what would I do the same next time versus what would I change? What are some things that I'm not doing so well? When you get into reviewing the questions, you don't want to just jump directly to reading the explanation for the ones you got wrong. And you also don't want to just ignore the ones you got right. Most importantly, you want to review every single problem. Okay. Why is that? Well, I forgot this point. Reviewing should take a long time. Reviewing your problem sets should take twice as long as doing them. And that applies also to cats, which means for a cat, you should be spending like a full day, maybe a day and a half, just analyzing it after you take it. Right? That's where the real learning comes from. People overemphasize the experience of doing the thing, and they underemphasize the value in reviewing it and thinking deeply about it. So before you reach for the explanation on a problem, first of all, figure out whether you got it right or wrong. Ideally, some systems like the MPrep cats will tell you which ones you got right and wrong without telling you the answers. If the system you're using tells you the answer when it tells you whether it was right and wrong, ask a friend or a parent or a partner or whoever to check the answers for you and just tell you these are the problems you got wrong. If you got a problem wrong, try it again with no time limit. Right? See if you can get it right with no time limit. Then check the answer, and just knowing the letter of the answer, if it's still wrong, can you back into the right answer? Can you figure out, okay, I know C's right. That's not what I picked. Can I back in and figure out why C is the right answer? Then when you read the explanation, instead of just reading the whole thing, cover it up with a note card or a piece of paper and read it bit by bit, basically using it as a series of hints. And if a hint comes to you, the third line in, you're like, oh, a light bulb goes off, try the problem again. Try and see if you can get it just with that hint and see if you can connect whatever dots there are remaining. What you're basically doing here is you're trying to figure out what is the hardest version of this problem that I'm capable of doing. The problem itself, I wasn't capable of doing. So let's make it a little easier. Take out the time limit. Then let's figure out, okay, know what the right answer is. Can I at least justify why? And at every step, you're making it a little bit easier rather than just jumping directly to the explanation. And you always want to record some sort of takeaway. What's your lesson? Most of the time, 80 or 90% of the time, when a problem doesn't go perfectly well, there's some flashcard that can come out of that. Some know the code, pattern recognition thing, or lesson to yourself about what you'll do differently next time. Crucial that you review the correct ones too. How come? Well, maybe you got lucky. A lot of the times you pick an answer, but it turns out your reasoning was totally off. You did it in completely the wrong way, and you just got lucky that C happened to be the right answer. Maybe you got it right in the right way, but you could have done it in such a smarter way. Like the problem we just did, you figured out that those 3 consecutive integers must be divisible by 3. Well, good for you. But if you just plugged in a smart number, the problem would have taken 10 seconds. So that's an important lesson to internalize. Right? Sometimes you're just not that confident about your reasoning, and that's still something you need to learn from. You should have been more confident if you had the right reasoning for the right, in the right way. Okay, so you definitely want to review all problems. And then you want to classify what kind of mistake you're making. This is crucial. So content mistakes are pretty straightforward, right? It was a problem about the area of a circle. You didn't remember the formula for the area of a circle. What's the solution? You go study the area of a circle, right? You make a flashcard with that formula on it. You drill it until you know that formula. Content is very straightforward as a type of mistake. The second type of mistake is code. What we mean by that is you missed a trip or a trap. Right? You fell into a trap or you missed, I said trip, you missed a trick is what I meant. So for example, you didn't make the connection that X in this problem was a prime number, and because it's a prime number, it can't be divisible by any other integer, and the problem involved maybe dividing it by 3, and you needed to realize that wasn't possible. Some sort of like, okay, I know prime numbers can't be divided by the number 3, but it didn't occur to me to apply that in this problem. That's a code issue, a trick or a trap issue. Those are a little bit harder to make flashcards about, but if you do a lot of them, you'll recognize the patterns in what you're doing well. The final one is careless mistakes, right? So you multiplied 7 and 5 and you wrote down 40 instead of 35. Key thing in the last 30 seconds here, careless mistakes should not be brushed under the rug. You want to make sure that you understand the patterns. If you make lots of careless mistakes in a row, what kinds of careless mistakes are you making? And then try and figure out a way to fix them. How do I avoid making a careless mistake? So one of the reasons I always write down a question mark is one of my careless mistakes is I solve for the wrong thing. So by writing down a question mark, I put up a safety rail that prevents me from doing that. Okay, we're going to skip this problem Yes, very quickly, I just want to talk about Manhattan Prep generally. We offer a free GMAT class. The first session is always free, so why would you not take us up on that? It's a free hour lesson from a professional instructor. It's really valuable, and it's not a fluffy class, that first session. It's a real hard 1 hour lesson. So definitely recommend doing that. If you do sign up either for a class or, yeah, if you sign up for any complete course through the end of the year, this class will give you a discount code for $75 off, GMAT Club 75. Note the capitalization there, GMAT, and the C in club are capital. So feel free to use that. And that's it. Thank you so much. I really appreciate you taking the time. I wish you all the best of luck on the GMAT and with everything beyond. I guess that's it. I'll stick around.